Hello and welcome. Myself, Mr. S.S. Mari, HOD Mechanical Engineering Department, Sharad Institute of Technology, Polytechnic, Etra. Friends, from today onwards, we are starting a lecture series on course Elements of Machine Design, which is introduced for third year Mechanical Engineering student, Diploma by MSBT under ISK. So, in today's first lecture, we will see Introduction to the Syllabus. Now, this course is Introduction for Diploma in Mechanical Engineering for semester 5th. The title of the course is Elements of Machine Design. The course code is 22564. Now, first of all, just go through the teaching scheme of this subject. Now, this course has 4 lectures per week and 2 hours of practical per week per batch. Now, just move towards the examination scheme which is allocated for this subject by an MSBT. Now, examination scheme has 2 components. One is theory component and one is practical component according to I scheme. Under theory component, again there are 2 components, that is end semester examination and progressive assessment. Under end semester examination, student has to appear for a theory paper of 70 marks. The minimum passing criteria is 28 marks. Under progressive assessment criteria, the 30 marks are allocated for progressive assessment. Under that, student has to undergo a class test of 20 marks. 2 class tests will be conducted. An average of 2 class tests will be considered as out of 20 marks, and 10 marks are allocated out of these 30 marks for micro project assessment. So total weightage of end semester examination component is 100 marks. The passing criteria will be 40 marks. The second component of this examination scheme is practical. Under practical component, again there are 2 components, end semester examination and progressive assessment. Under end semester examination, student has to undergo a practical examination of 25 marks which will be conducted at the end of the semester. The minimum passing criteria will be 10 marks and a progressive assessment of 25 marks which will be carried out during the course of semester. The passing criteria will be 10 marks. So total there will be 50 marks from these 2 components and the passing criteria will be minimum 20 marks. So this is regarding the teaching scheme and examination scheme of course Elements of Machine Designs, which is introduced for Diploma in Mechanical Engineering for 5th semester under ISK. Now move towards the introduction to syllabus. So before going into the syllabus, we will see what is the significance of introducing this course for the third year mechanical engineering students. We know that in an organization, a design department is one of the important department of an industry, where a diploma engineer can secure a job profile. So one of the major job areas for the diploma technicians is the design department. So under this category, the diploma students should be able to design a simple machine components which will be depend upon the selection of proper materials, selection of the proper design procedures, understanding the different codes, understanding the different procedures. So after passing out or after undergoing this course, after passing out, a diploma holder or diploma student should able to design a simple machine components as one of the major perspective according to job concern. So before that, the student should have the fundamental knowledge of different basic areas, that is applied mechanics, strength of materials, engineering materials, theory of machines, and computer-aided design and drafting. Students already undergone all the courses in previous semesters. In second semester, applied mechanics. In third semester, strength of material, engineering materials. In fourth semester, theory of machines and CAD. So by having a basic knowledge of these subjects, it will be easy for all the students to understand the concepts of this course, that is the elements of machine design. So major focus while introducing this subject for the third year mechanical engineering by the MSPT is to enable the students to work there. He should know how to design the simple machine elements. Means when student will enter into the organization, he should able to select a particular design procedures, material selection procedures. He should have a basic knowledge of codes, different norms which are given by the different societies, and guidelines for selection of the appropriate material. This subject aims at developing analytical and selection abilities. The major concern regarding the students, the major skill, that is the motor skill, what we can say, affirmative, cognitive and motor skill, that is should be developed into the student, is the analytical abilities of the diploma holders and selection abilities, which will produce or give solutions to the simple engineering design problems using standard procedures. So main aim of this course is to understand or to develop solutions to the simple engineering design problems using the standard procedures. Students should be able to understand different standard procedures which are used for developing engineering solutions regarding the design aspects. So while framing the syllabus, the MSPT has taken the feedback from different industries for framing the contents. And one of the industry identified competency through this subject is design simple machine components. So what we can say in conclusion, the major aspect of introducing this course for third year mechanical engineering student is to able the students to design a simple machine components. So this is the rationale of what we can say a scope of the subject, or what we can say a significance of studying this course for third year mechanical engineering students. Now move towards the course outcomes. Now course outcomes. Course is the elements of machine design. Course outcomes means at the end of this course, when a student will learn this course or study this course during the 5th semester, at the end of the 5th semester, through different theory components, through different practical experiences, the skills which are associated with this course to be developed or taught into the students. That means at the end of this 5th semester, when student will undergo this theory and practical component, he should able to, means student should able to, that is termed as the outcome of this course. Now there are total 6 course outcomes that are taken from this course. Each course outcome is assigned with one topic, means at the end of that topic, when student will undergo the theory components as well as the practical components associated with that unit or topic, the student should able to. Now the first course outcome is select suitable materials for designing machine elements. Now this first topic is fundamental of machine design. With concern to this topic, the first course outcome is taken, that is the select suitable materials for designing machine elements. Means after studying the first topic, first unit, student should gain a certain knowledge that he should able to or she should able to select a suitable materials for designing a particular element. Means before the selection of design procedure, before calculation of the stresses, before calculation of the applied load, that student should able to select a particular material by identifying its properties, by studying its properties for a particular application for which that element is proposed to be designed. That is the main aim of this first course outcome, that student should able to understand the material properties. Now this second course outcome is design joints and levers for various applications. Now this course outcome is taken from the second topic, that is the design of joints, levers and offset links. Now in first course outcome, student had understood how we can select the material for designing a machine element. Now from this second course outcome, students has to actually design various elements. Now in second course outcome, the students should able to design joints and levers. Now these are the two components, joints and levers. The third course outcome is design the power transmission elements like shaft, keys and couplings. Now this third course outcome is taken from third topic, that is the design of shaft, keys and couplings. That means these are again three components, shaft, keys and couplings. So students should understand, students should learn how to design these power transmission elements like shaft, keys and couplings. Now again fourth course outcome is recommend or select or suggest or choose power screws and suitable fasteners, means threaded joints, screwed joints and welded joints for different applications. Again this fourth course outcome is taken from or which is associated with the fourth unit, that is design of power screws and fasteners. Means after studying this topic, that is the unit number 4, students should able to recommend or choose or select different power screws and fasteners for different applications. Now fifth course outcome is, that is after studying the fifth topic, that is design of springs. What qualities or what learning domains should implemented or what should be implemented by the students, what should student understood, what should student understand at the end of the topic, that is he should at least able to choose springs for various applications. Though he has to design the springs, but at least he should able to choose springs for various applications. Now, sixth course outcome is select standard components with their specifications from manufacturers' catalogs, which are associated with the sixth topic, that is the selection of bearings from the manufacturer catalogs and the gears. So these are the course outcomes, that is the expected learning outcome of the students when that students will undergo a course elements of machine design. So what we can say, these are the some different evaluation criteria that student should fulfill when he will undergo this course. So this is regarding the course outcomes. Total 6 course outcomes which are associated with the subject, which are taken from the 6 units. Now just move towards the syllabus. Now first topic of this course is fundamentals of machine design. The 14 marks are allocated to this topic. What we have to see in this topic, what we are learning from this topic, as the name suggests, it is the fundamentals of the machine design. Means it is the introductory part which is introduced for the subject elements of machine design. Now its bit number 1.1 includes what is meant by the machine design and its philosophy. Means what is the need of the machine design, how this machine design is concerned with the different aspects of the industrial organization. What are the different phases in the design of the machine component? Phases means different procedures, different steps in design of machine component. And what are the design considerations? Design considerations means what are the facts that need to be considered while designing a particular component. In simple language, we can say these are some different criteria that should be taken into account while designing a particular machine component. So in bit number 1.1 we are studying the machine design philosophy, what is meant by the machine design, what are the different steps that are included in a machine design, what are the different criteria that we need to consider while designing a particular machine component. That we are studying in bit number 1.1. Now in bit number 1.2, after understanding the concept of machine design, after understanding the steps involved in the design procedure, after understanding the knowledge, after understanding the logic behind the design of machine component, after understanding the different criteria, different considerations, how we can design, or what are the different aspects, factors that we need to consider while designing a machine component. The next part is to study the different types of the loads that came into picture when a particular machine component subjected to the application. Means when a particular machine component undergoes a particular application, at that time different types of the loads that are applied on the machine components that we need to study it. And due to the application of these different types of loads, there is an induction of the stress into the component. So after application of load, what are the different types of the stresses that has been induced in the component that we have to study under the concept of stresses, because this is the basic for the design of any machine component. That means by taking into account the nature of stress that is induced in the machine component, we have to design a particular machine component. So we have to study the different types of the stresses that are introduced in the machine component. Again, there are different types of stresses, that is the bending and torsional stresses, direct stresses, that is the tensile, compression and shear, and we have to study the stress strain diagram. Already we have studied this diagram in course Strength of Materials. So we have to just revise these concepts in this topic. Next part is the factor of safety and conditions for selection of factor of safety. While designing any particular machine component, it is very necessary to understand the concept of the factor of safety. That is how we have to select a factor of safety. So in this part we will study what is meant by the factor of safety, how this factor of safety is concerned with the ductile and brittle materials, and how we have to select a factor of safety for particular applications. The next part is the stress concentration. Here we have studied the different types of stresses, but here we have to study how these stresses are concentrated at a particular point. What is the causes of having a stress concentration in a particular element when that machine component is subjected to the different kind of the applications. We can't remove stress concentration from a component, but we can reduce its intensity. That's why we have to find out the different remedies, how we can reduce the stress concentration at a particular point in a component. Next part is the designation of materials. According to the IS, means international standards, as well as the Indian standards, that is the Bureau of Indian Standards. Introduction to international standards. Now, designation of a material means how we can designate. Suppose I want to purchase a particular component, or I want to select a particular material. There are different types of the materials. If I want to select a particular material for a particular application, before that I should know its properties, its chemical composition. So that chemical composition, its mechanical properties, we will get when we will designate that particular material. Means what is its tensile strength, what is its yield strength, what is the percentage of carbon, what is the percentage of different alloying elements. That we get when we understand how the materials are designated. That is most important part. And introduction to different international standards. Means when we design a particular component, then we have to refer a particular standard, and by referring that particular standard, by a particular theory, by a particular procedure, we have to design a particular component. That's why it is necessary to understand the international standards before actually going into the design of the particular component. Again, advantage of the standardization. What is known by the standardization? Why the standardization is needed? How a design engineer can use these standard components for designing a particular element, for assembling of a particular element. So that part come into the standardization. Next part is the concept of creep, fatigue and endurance limit. Now these three properties are concerned with when the components are subjected to fluctuating loads. We know that tensile, compressive, shear stresses are induced in the component when these are subjected to static and dynamic loads. But when the components are subjected to fluctuating loads, these properties play an important role while designing a particular component. That's why it is very necessary to understand the concept of this creep, fatigue, ascent curve and endurance limit that we have to see under this 1.6 bit. 1.7 bit focus on the different types of the stresses, different types of the stress theories. That is the maximum principal stress theory and maximum shear stress theory. For a particular diploma syllabus, we have to only focus on these two types of the theories, though there are different types of the theories, but for subject point of view, we have to focus on these two types of the theories, that is the maximum principal stress theory, maximum shear stress theory, how these theories are used to design a component depending upon whether it is a brittle or ductile material. Last is the 1.8 modern designing considerations. Under modern design considerations, after designing all the components, the major part that we have to focus as a design engineer, that is the ergonomics and aesthetical considerations in a design, because these are the two components are playing a very important role when we are designing a product. Up to this point, we are only determining the dimensions of the component by designing a component, but here we have to focus on the aesthetic and ergonomical considerations that will appeal to the customers for purchasing that product, as well as when the product will be utilized by an end user. So this is regarding the unit number 1, that is the fundamentals of machine design, where we have seen the different introductory part for this subject. Just move to the next topic. Now from topic number 2 onwards, we have to actually design different components. In first topic, we have just seen the introductory part of machine design subject. From unit number 2, actually we have to go into the design of different elements. Now design of different elements means to determine the dimensions of different elements by considering the nature of load, by considering the nature of stress induced in the component, by considering application, by considering design procedures, by considering criteria, by considering materials, we have to design different components. In unit number 2, we are designing joint, lever and offset links. This topic is divided for 12 marks. Under 2.1, we are designing quarter joint, knuckle joint and turnbuckle. And here we have to actually see the applications of these three components: quarter joint, knuckle joint and turnbuckle. Now actually designing of a component means, first of all we should understand what is the load, what is the value of load acting on these components. We have to understand the resisting area of this component, and we have to determine the value of stress which is induced in this component, in the nature of stress, whether it is a tensile, compressive, shear or bending. By understanding these three criteria, while designing any machine component, we have to understand these three factors: load, stress, nature of stress, magnitude of stress and the value of resisting area. So under 2.2, we have to design levers for our subject. It is restricted to only three types of the levers, that is the hand foot lever, bell crank lever and lever for safety valve. Under 2.3, design of offset links such as C-clamp and overhang crank. So under topic number 2, we have to design these three components: joint, lever and offset link. Now move towards third topic, that is design of shaft, keys and couplings. Now these all components are concerned with the transmission system. Under CO3, we have seen the course outcome, that is the design of transmission elements like shaft, keys and couplings. So under this we have to study the shaft, keys and couplings. Under that we have to study the types of the shafts, what are the different shaft materials, what are the different standard sizes of the shafts are available in the market. Again, there are two types of the shaft, that is the hollow shaft and solid shafts. And these two shafts again designed on the basis of strength and rigidity criteria. That is the consideration, design considerations, design criteria, strength and rigidity criteria. Again, these hollow and solid shafts are designed when these are subjected to bending and twisting moments, considering the effect of shock and fatigue. And for that we have to use the ASME code of design. When the shafts are supported in bearings with one or two pulleys in between, as we have know that shafts are used for the transmission of power, transmission of torque. So pulleys are also mounted on the shaft to have accommodation of the belts over them, so that we can transmit the power from the shaft to the another device, or from the motor to the shaft. So by considering this, we have to design hollow and solid shafts. The next part is the design of key. Under that we have to study the different types of keys, what is named by the key and different types of the keys, and what is the effect of keyway on the strength of the shaft. Now keyway is a rectangular slot which is provided on the shaft for the accommodation or for inserting key into it. When we have that slot, what will be the effect of that slot on the strength of the shaft, that we have to see here. For our subject point of view, we have just restricted to the rectangular and square sunk key, that is the design of rectangular and square sunk key. Now next part is the types of couplings. Now to couple means to join. When we have to transmit the power for a longer distance, then we have to join two or more shafts to each other. That task is carried out by using the different couplings. For our topic, our unit, it is restricted to muff coupling, flange coupling and bush pin type flexible coupling. So we have to design muff coupling, flange coupling and bush pin type flexible coupling. This is regarding the topic number 3. Now this unit number 3 is important according to the subject point of view, that is the examination point of view. Now unit number 4 is the design of power screws and fasteners. Already at 12 marks. Now under that we have to design two components, that is the power screws and fasteners. Fasteners means welded, threaded and bolted joints which are used as the temporary as well as the permanent joints. So under design of power screws, first of all we need to understand the basic concept of power screw. What is meant by the power screw? What is the use of power screw? Why power screws are used? Where these power screws are used? Now, depending upon power screw, there are different thread profiles. That is the square thread, Acme thread, V threads. So we have to see the merits and demerits of these thread profiles. Then self-locking and overhauling properties of these power screws. What is meant by the self-locking power screw? What is meant by the overhauling power screw? Torque required to overcome the thread friction. Now as we know that power screws are used for the lifting and lowering the loads by the application of a small amount of load. That is the main consideration why we are using the power screws. That's why these are termed as the power screws. Because while lifting a major portion of load by the just application of a small amount of effort, we can lift that load. That's why these are termed as the power screws. So while lowering or while lifting the load, what is the torque required to overcome the thread friction? It is nut and thread. In the vicinity of the nut and thread, what is the thread friction? What is the torque required to overcome this thread friction? The efficiency of the power screws. The types of the stresses induced in that power screws. Next part is the design of screw jack, which is concerned with the power screw. Now this is restricted only up to screw and nut. Now 4.3, under 4.3 we have to understand what are the different types of the stresses introduced in screw fasteners. Up to 4.2 we have understood what is meant by the power screw, design procedure of power screw and different stresses induced in thread profiles or threads. But from 4.3 we have to see what are the different stresses induced in fasteners, that is the bolts, screw joints and welded joints. Under 4.3 we have to see bolt of uniform strength, that is the design of bolted joints subjected to eccentric loading. Under 4.4 we have to see what is meant by the design of parallel and transverse fillet welds. And this is regarding the bolted joints, this is regarding the welded joints. When that welded joint will be parallel and when that welded joint will be fillet weld. We have to design means we have to determine the dimensions. Again keep in mind, when we are saying designing a machine component is nothing but determining the dimensions of the machine component. We have seen the quarter joints, we have seen the knuckle joint, turnbuckle, lever, shaft, keys, couplings. In all these elements, the basic fundamental task that we have to carry out is to understand the different stresses induced in the component, nature of the stresses induced in the component, and determining the dimensions of the component. That is nothing but the design of a machine element. In conclusion, so keep in mind, when we are saying we are designing something, that means we are actually determining the dimensions of the particular component. Just move to the unit number 5, that is the design of springs. Again we have seen course outcome number 5, that is choose a particular spring for a different application. So before choosing a particular spring, we should understand what is meant by the spring, what are the different types of the springs, and what are the different criteria for using a particular spring for a particular application. So under this classification and application of springs, we have to see the different types of the springs. But our study is restricted with the helical tension and compression springs. Before that, we need to understand the different spring terminology. Spring terminology means concepts which are associated with the spring. That is the major diameter, minor diameter, what is meant by the coil diameter, what is meant by the wire diameter, what is meant by the number of turns of coils. So these are the basic, what is the pitch, These are the basic terminologies which are associated with the springs that we have to study. As I have told you that our design is only restricted with the helical tension and compression springs. The use of Wahl's correction factor while designing a springs, how the deflection of springs carried out, and what is the energy stored in the springs. The major function of the spring is to store the energy and use that stored energy for a particular application. That is the major task of the spring. That's why we need to understand how this energy is stored in the springs. The next part is the design of the helical tension and compression springs when the springs are subjected to concentric applied loads. That is IC engine valves. Many of you have seen the valves which are located on the IC engine cylinder, that is inlet and exhaust valves, how these valves are operated with the help of the spring. Weighing balance, weighing machine or weighing balance, and railway buffers. So these are the different applications of the springs, that is the helical and tension and compression springs. That springs we have to design for this particular applications. Again, designing of springs is nothing but to determine its major diameter, its minor diameter, coil diameter, number of turns, free length, compressor length, and pitch of the spring. Next part is the leaf spring. There is only introduction of the leaf spring. There is no design procedure for the leaf spring. We have just a brief introduction of the leaf spring, that is the construction and applications of the leaf spring. Actually, in this chapter, we have to design helical tension and compression spring, but we have just the introduction of the leaf springs. This is regarding to chapter number 5. The last chapter, that is last unit of this course, is selection of anti-friction bearings and gears. Again, you know that what is the use of the bearings, what are the applications of the bearings. When there is two rotating parts, or one stationary part, one rotating part, or two sliding parts, two moving parts, and when these two parts moves, there is a possibility of the friction between the two mating parts where they get joined or mated. So to avoid this friction, to have a frictionless power transmission, these bearings are introduced. Again, there are major two categories of the bearing, that is the sliding contact bearing and the rolling contact bearing. For our subject point of view, it is restricted with the rolling contact bearing, that is the ball bearings. So we have to see what is the classification of the bearings, what is meant by the bearing, what is the use of the bearing in designing the machine component, and what is the comparison of sliding contact and rolling contact bearing. So this comparison will give an idea when we have to select a particular bearing for a particular application. In what application we have to select which kind of a bearing. The basic terminology of the bearing, that is the life load relationship, basic static load rating and the basic dynamic load rating. These are the terminology of the ball bearings. The major most important part is the selection of ball bearing using manufacturer catalog. This is our course outcome number 6. There is a selection of a particular element, particular component, particular bearing from the manufacturer's catalog. Different manufacturer's catalog are available, but for a particular application we have to select a particular bearing by considering life load relationship, basic static load, basic dynamic load, its cycles, the load application, nature of load application, where it is used. By considering these all parameters, we have to select a particular bearing from a manufacturing catalog. Last part is the design of spur gear, Lewis and Buckingham's equation and selection of the gear. Now in this case only the introduction of the spur gear is introduced. There is no need to design a particular spur gear, but only introductory part is there for this subject. By using the introduction to the Lewis-Buckingham's equation, different gear failures. What are the criteria of the gear failures? What are the different types of the gear failures? How failure of the spur gear took place? Now all these things we have to undergo through this bit number 6.4, where we have to study how the failure of the gear takes place, what is meant by the spur gear, the terminology of the spur gear, the strength equations which are used for the design of the spur gear, that is the Lewis equation and Buckingham's equation, and how a selection of a particular gear carried out. So this is regarding the unit number 6, that is the selection of anti-friction bearings and gears. So there are total 6 topics that we have seen right now. Fundamentals of machine design, topic number 1. Second topic, design of joints, levers and offset links, topic number 3. Design of transmission elements like shaft, keys and couplings, topic number 4. Power screws, design of power screws and threaded joints, topic number 5. Design of springs, and topic number 6. Selection of anti-friction bearings and gears. So these are some suggested learning resources, means these are some suggested reference books that students can refer to go through the different topics. The first one is the Design of Machine Elements by V.B. Bhandari. A simple book is there. You can refer this book, Design of Machine Elements. That is the V.B. Bhandari. These are the all books are available in our library. A book of machine design by Khurmi Gupta. A book of machine design by Pandya and Shah. A book of mechanical engineering design by Shingley and McGraw. Shingley, McGraw Publications. Now it is a design data book, which is the PhD publication. Now design data book, the student should understand how to use this design data book. Let them have just an introduction how to use this design data book. That will be the most important criteria or most important aspect of this course, that students should understand the use of design data book. So these are the some reference books that students can refer while undergoing, while learning or while understanding the different concepts of this course, that is the elements of machine design. So this is regarding the introduction to syllabus of course elements of machine design, which is introduced for the diploma in mechanical engineering, semester 5th, under I scheme by Maharashtra State Board of Technical Education. From next lecture onwards, we will actually undergoing the different topics of course. I hope so you understood the introduction to the syllabus. Thank you.